Welcome to the future.
Welcome to a new chapter of Transhumanism. My name is Justo, and today we're going to discuss the history of brain-computer interfaces, a journey from science fiction to reality. The idea of controlling machines with thought has captivated the human imagination since time immemorial. Science fiction has shown us worlds where thoughts can move objects and where the human mind merges with artificial intelligence. However, what once seemed an unattainable dream is quickly becoming reality thanks to advances in neuroscience and technology. Let us now examine the pioneers, those who have sown the seeds of the revolution. The origins of brain-computer interfaces, BCIs, date back to the late 19th century when physiologist Richard Cotton made the first recordings of brain electrical activity in animals. However, it was Hans Berger, a German psychiatrist, who in the 1920s was the first to record human brain waves using an electroencephalogram, EEG. This milestone marked the beginning of a new era in neuroscience and laid the groundwork for the development of BCIs. Throughout the 20th century, numerous researchers devoted themselves to exploring the possibilities of brain-machine interaction. Science fiction, with works such as Philip K. Dick's The Electric Man, greatly influenced the imagination of these pioneers, who dreamed of creating devices capable of reading and writing within the human brain. As the 20th century progressed, significant advances were made in the field of BCIs. The development of more precise brain recording techniques, such as magnetoencephalography, MG, and functional magnetic resonance imaging, fMRI, allowed researchers to obtain increasingly detailed images of brain activity. Furthermore, advances in computing and the miniaturization of electronic devices made the development of more sophisticated and portable BCIs possible. The 1970s were a turning point with the introduction of the term brain-computer interface by Jacques Vidal. From that moment on, research in this field intensified, and the first successful experiments were conducted in which people with paralysis were able to control external devices using brain signals. The digital revolution of recent decades has further accelerated the development of BCIs. Growing computing power and advances in machine learning algorithms have allowed researchers to decode increasingly complex brain signals and develop more intuitive and efficient interfaces. In recent years, we have seen a number of significant advances in the field of BCIs. Projects such as Elon Musk's Neuralink have captured media attention and generated great excitement around the possibilities of this technology. Furthermore, significant progress has been made in the application of BCIs in the medical field, with the development of neural prostheses that allow people with disabilities to recover motor and sensory functions. The future of BCIs is full of promise. These technologies are expected to revolutionize fields such as medicine, communication, and human-machine interaction. However, they also pose significant ethical and social challenges that must be carefully addressed.